Hello friends, now we'll start the new chapter, pair of straight line. This chapter is for the 6 marks in the board examination. I will explain all the theoretical parts, short examples and all the examples from the exercise 4.1 in this video. Now let us start. Pair of straight line. Now in this chapter we will learn combined equation of pair of lines, homogeneous equation of degree 2, angle between lines, and general degree equation in x and y. Now the introduction. We know that equation ax plus by plus c is equals to 0, where a, b, c belongs to set of real number. A and b not simultaneously 0. If both are 0, then it will be not line. Represent a line in xy plane. We are familiar with different forms of equation of a line in 11th standard. Now let us study two lines simultaneously. For this, we need the concept of the combined equation of two lines. It's very simple. Now let's learn. Combined equation of a pair of lines. An equation which represents two lines is called the combined equation of those two lines. Let u is equals to a1x plus b1y plus c1 and v is equals to a2x plus b2y plus c2. Equation u is equals to 0 and v is equals to 0 represent lines. We know that equation u plus kv is equals to 0, where k belongs to set of real number, represent a family of lines. Let us interpret the equation u into v is equals to 0. Every point which satisfies the equation u into v is equals to 0 lies on one of these two lines, that is u is equals to 0, or the line v is equals to 0. Therefore, equation u into v is equals to 0 represent the combined equation of the lines u is equals to 0 or v is equals to 0. Now the remark. The combined equation of a pair of lines is also called as the joint equation of pair of lines. Equation u is equals to 0 and v is equals to 0 are called separate equations of the lines represented by u into v is equals to 0. Now see the solid examples. Very interesting. Find the combined equation of the lines x plus y minus 2 is equals to 0 and 2x minus y plus 2 is equals to 0. The combined equation of the lines u is equals to 0 and v is equals to 0 is u into v is equals to 0. The combined equation of lines x plus y minus 2 is equals to 0 and 2x minus y plus 2 is equals to 0 is their joint equation. That is the product of that two lines is equals to 0. Now in first bracket x plus y minus 2. In second bracket 2x minus y plus 2 is equals to 0. Normal product is there. That is x will multiply to this whole bracket, y will multiply to this bracket and minus 2. And after multiplication you will get x into 2x, that is a 2x square. X into minus y minus xy, x into 2x plus 2x, y into 2x, that is a plus 2xy, plus y minus y, that is a minus y square, y into 2, that is a 2y, minus 2 into 2x minus 4x, minus 2 into minus y, that is a plus 2y, minus 2 into plus 2, that is a minus 4, and that's equals to 0. And therefore, the joint equation is a 2x square. How many xy's are there? This is a minus xy and plus 2xy. Overall, you will get here plus xy. Next is the terms of the y square, is a single one. The terms of the x, here is a plus 2x and minus 4x. Then you will get minus 2x. And what about the y? the terms of y. Here is a plus 2y and plus 2y. That will make the 4y minus 4 and that's equals to 0. Therefore, the joint equation is 2x square plus xy minus y square minus 2x plus 4y minus 4 is equals to 0. Now the second, find the combined equation of the lines x minus 2 is equals to 0 and y plus 2 is equals to 0. The combined equation of the lines u is equals to 0 and v is equals to 0 is u into v is equals to 0. That is the product of that two lines. Here is a x minus 2 is the first line and second line is a y plus 2 and their product. In first bracket x minus 2, in second bracket y plus 2, that's equals to 0. Their product x into y, x into 2, minus 2 into y, minus 2 plus 2, minus 4. And hence xy plus 2x minus 2y minus 4 is equals to 0. Okay. Next, find the combined equation of the lines x minus 2y is equals to 0 and x plus y is equals to 0. Again, the combined equation of the lines, same dialogues are here. U is equals to 0 and v is equals to 0 is u into v is equals to 0. The combined equation of the lines x minus 2y is equals to 0 and x plus y is equals to 0 is in first bracket x minus 2y into second bracket x plus y is equals to 0. Now their product x into x square, x into y. Then you will get plus xy. And for this term, that is a minus 2xy into this x, then you will get minus 2xy. And that of the 1 plus xy, overall you will get here minus xy. And the last term is minus 2y into y, then you will get minus 2y square. Okay. Now the next is find the separate equation of the lines represented by. Up to the example number 1 to 3, we have learned the combined equation of the line. Now we will separate the lines. Now first is x square minus y square plus xy is equals to 0. We factorize the equation x square minus y square plus xy is equals to 0 as the factors of x minus y, x square minus y square are x plus y in first bracket and second bracket x minus y plus x plus y is equals to 0. Now from this we will take the x plus y as a common. Then you will get x plus y as a common. Then what is the remaining? The another bracket x minus y and here is that of the plus 1. Therefore, the separate equation, the required separate equations are x plus y is equals to 0 and x minus y plus 1 is equals to 0. Now next is a homogeneous equation of degree 2. Homogeneous means what? The sum of the powers of each variable is equals to 2, the constituent in that equation. Now see, this is the homogeneous equation of the degree 2. Degree of a term. The sum of the indices of all the variables in a term is called the degree of the term. For example, in the expression x square plus 3xy minus 2y square plus 5x plus 2, the degree of the term x square is 2. The degree of the term x 3xy, here the degree of the x is 1 and y is 1. 1 plus 1, that is 2. The degree of the term minus 2y square is also 2. The degree of the term 5x is 1. The degree of the constant 2 is 0 and the degree of the 0 is not defined. Now the homogeneous equation. An equation in which the degree of every term is the same is called a homogeneous equation. For example, x square plus 3xy is equals to 0. This is, and 7xy minus 2y square is equals to 0. These are the homogeneous equation because the degree of x square is 2 and x is 1, y is 1, x plus 1, that is 2. 7xy minus 2y square is equals to 0. Again the degree is 2. 2x square plus 3xy minus 2y square is equals to 0. Again the degree 2 are homogeneous equations. But 3x square plus 2xy plus 2y square plus 5x is equals to 0 is not the homogeneous equation, though the degree of x square 2xy plus 5x square 5y square is 2. But one term is that the 5x whose degree is 1, whose exponent of x is 1, and therefore it is not the homogeneous equation. Homogeneous equation of degree 2 in x and y has a form ax square plus 2hxy plus by square is equals to 0. This is very important equation and you want to remember this equation. You have to remember this equation. Now the theorem. The combined equation of a pair of lines passing through the origin is a homogeneous equation of degree 2 in x and y. When we combine the equation and whatever that equation will be formed, that will be of the degree 2 in x and y. This is the meaning of this theorem. Now see this here. In figure, you can see this. The x, that is a1x plus b1y is equals to 0. The lines are passes through the origin. Second is a2x plus b2y is equals to 0. These two lines passes through the origin. Let a1x plus b1y is equals to 0 and a2x plus b2y is equals to 0. Be any two lines passing through the origin. These two lines passes through the origin and their combined equation means what? Their joint equation. That is the product of the first line and the second line is equals to 0. Now here a1x plus b1y into in second bracket a2x plus b2y is equals to 0. Now their product a1x into a2x, then you will get a1 a2x square. a1x into b2y, then you will get a1 b2 xy. Then b1y into a2x, then you will get a2 b1 xy. And the last is b1y into b2y, then you will get b1 b2 y square, and that's equals to 0. And again we will write here a1 a2 into x square plus a1 b2 plus a2 b1 bracket complete, take xy as a common plus a b1 b2 bracket complete into y square, and that's equals to 0. Now we'll substitute the sum terms. That is the product of this constant a1 a2 is a1 b2 plus a2 b1. Suppose that is equals to again another constant which is the 2h, and b1 b2 that is equals to b. And if we substitute in above equation, in this equation and this equation, that is a1 a2 is a1 b2 plus a2 b1, this is the 2h, and b1 b2 is b, and therefore the ax square plus 2hxy plus by square is equals to 0, which is a homogeneous equation of degree 2 in x and y. Now verify that the combined equation of the lines 2x plus 3y is equals to 0 and x minus 2y is equals to 0 is a homogeneous equation of the degree 2. Now we'll form their product. The combined equation of the lines u is equals to 0 and v is equals to 0 is uv is equals to 0. The combined equation of the lines 2x plus 3y is equals to 0 and x minus 2y is equals to 0. Now their product 2x plus 3y in first bracket, second bracket x minus 2y is equals to 0. Now their product 2x into x, you will get 2x square. 2x into minus 2y, you will get minus 4xy. And next is a 3y into y, then you will get plus 3xy. Now minus 4xy plus 3xy, you will get minus xy. Again the product of plus 3y minus 2y, you will get minus 6y square, which is the homogeneous equation of the degree 2. Remark, the combined equation of a pair of lines passing through origin is a homogeneous equation of degree 2. But every homogeneous equation of the degree 2 need not represent a pair of lines. For example, the equation x square plus y square is equals to 0. This is the homogeneous equation of the degree 2. but it does not represent a pair of lines. How to test whether given homogeneous equation of the degree 2 represent a pair of lines or not? Then we want to test it. And then how to test it? Then we have, this is the theorem. What is that? The homogeneous equation of the degree 2 in x and y, ax square plus 2hxy plus by square is equals to 0, represent a pair of lines passing through the origin if hs square minus ab is greater than 0. Okay. Then we say that it represents a pair of lines passes through the origin. Consider the homogeneous equation of degree 2 in x and y. That is the ax square plus 2hxy plus by square is equals to 0. Consider the two cases. Now first case, that is the b is equals to 0, and second is b is not equals to 0. These two cases are adjusted. Now first case, if b is equals to 0, then what will happen? In this equation, if we substitute b is equals to 0, then you will get ax square plus 2hxy, and here is the ax square plus 2hxy is equals to 0. Now from this equation, you will take x as a common, and therefore x in bracket ax plus 2hxy is equals to 0, which is the combined equation of the lines x is equals to 0 and ax plus 2hxy is equals to 0. We observe that this line passes through the origin. And now second case, this is very important case. If b is not equals to 0, then multiply this equation, that is the ax square plus 2hxy plus by square is equals to 0 by b, and then you will get, that is abx square plus 2hbxy plus b square into y square is equals to 0. Now this equation again can be written as b square y square plus 2hbxy minus abx square. To make LHS the complete square, we have to add, that is the h square x square, to have it's a perfect square. Now what will be the second term? To find out the second term, we want to divide this equation by the 2 and the b into y. Then you will get hx. Okay. And from this equation, again you can get the second term. Then how to find out that second term? Here is a 2, it's a common. The first term is a by, and suppose this is a 2hbyxy. Here is a 2hbxy असेल तर हे मी कसं split up करू शकतो? 2 in bracket by into which terms are remaining now? The h and x. This is the h and x, and you will get that is the hx as the second term, and it's a square, that is the hs square x square. Add hs square x square on both sides, and therefore b square y square plus 2hbxy plus hs square x square, this is the perfect square of by plus hx, plus sign for the middle term, and it's a bracket square. Now from the right hand side, you can take x square as a common. Then in bracket you will get hs square minus ab bracket complete into x square. Now take this equation can be again written as by plus hx bracket square, and hs square minus ab can be written as in root of hs square minus ab bracket square into this x square, where we have considered that hs square minus ab is greater than or equals to 0. Now again this can be written as by plus hx bracket square minus, bring this term to the left hand side, then it will become minus in root of hs square minus ab bracket square into x square, and that's equals to 0. Now this is of the form. Which is the form? We know the formula from the 8th standard, that is a square minus b square, and we can write here in first bracket their minus and second bracket the plus, and in this way by plus hx plus in root of hs square minus ab, in second bracket by plus hx minus in root of hs square minus ab bracket complete, that is a root complete into x, that's equals to 0. And here we can write here, that is from these terms which terms, that is hx plus in root of hs square minus ab into x. We will take x as a common, and then if you take the x as a common, then in bracket you will get in bracket h plus in root of hs square minus ab bracket complete into x plus by. And for the second bracket, again from these two terms you can take x as a common. Then in bracket you will get h minus in root of hs square minus ab bracket into x plus by is equals to 0, which is the combined equation of the lines h plus in root of hs square minus ab into x plus by is equals to 0, and h minus in root of hs square minus ab bracket complete into x plus by is equals to 0. As b is not equals to 0, we can write these equations in the form y is equals to m1x and y is equals to m2x. What is the slope of the first line? That is a m1 is equals to, from this, that is a by is equals to minus in bracket h plus in root of hs square minus ab, and this is a b is a multiplied. Therefore, you will get divided by b, that is a minus h minus in root of hs square minus ab upon b. What about the second? In this case, if this term being this term to the right hand side, then you will get it's a minus. That is, here is a, suppose that here is a by, and that is equals to minus h minus in root of, this is the hs square minus ab bracket complete, okay, into x. Therefore, what is the y is equals to? That is y is equals to minus h in root of hs square minus ab into x, and this whole divided by x, okay, and therefore, this whole divided by b, okay, this whole divided by b. Therefore, the slope of the line is, if we operate the negative sign, then you will get here minus and plus, minus and plus. Therefore, m2 is equals to minus h plus in root of hs square minus ab. Okay, this is the slope of, and similarly we can find out the m1 also. We observe that these lines pass through the origin, and therefore abx square, that is a abx square plus 2hbxy plus by square is equals to 0. And therefore ax square plus 2hxy plus by square is equals to 0 represent a pair of line passing through the origin if hs square minus ab is greater than or equals to 0. Remark, if hs square minus ab is greater than 0, then lines represented by ones are distinct. If the hs square minus ab is equals to 0, then the lines represented by above lines is coincident, and hs square minus ab is less than 0, then the equation 1 does not represent a pair of lines. These are the important conditions. If b is equals to 0, then one of the lines is y is equals to 0, whose slope is not defined, and the slope of the other line is minus a upon 2h. Okay, if hs square minus ab is greater than or equals to 0 and b is not equals to 0, then the slopes of the lines are m1 is equals to minus h minus in root of hs square minus ab upon b, and m2 is equals to minus h plus in root of hs square minus ab upon b. Sum of their slopes m1 plus m2. If we add these two equations, and now see this is minus and the plus, that will get cancelled, and you will get minus h and minus h minus 2h upon b. Their product, if we take their product, that is what is your m1 into m2, then you will get, this is the minus h minus in root of hs square minus ab minus h plus in root of hs square minus ab. Then you will get hs square minus in bracket hs square minus ab. If we open the bracket, then plus hs square minus hs square get cancelled, and you will get, that is a plus 2, here is a, that will get cancelled, and here you will get, that is the ab upon b square, ab upon b square. Okay, then bb will get cancelled, and here m1 into m2 is equals to a upon b. Again I will repeat here, their sum of the slopes, that is m1 plus m2 is equals to minus 2h upon b, and the product is m1 into m2 is equals to a upon b. The quadratic equation in m whose roots are m1 and m2 is given by m square minus in bracket m1 plus m2 into m plus that is the b m square minus in bracket m1 plus m2 into m plus m1 into m2, that's equals to 0. And now here the first is we'll substitute the value of m1 plus m2, that is a minus 2h upon b, and m1 into m2 is a upon b. And then you will get here, that is a m square, what is here? M square plus 2h upon b plus a upon b, and that's equals to 0. Now multiply this whole equation by b. Then you will get bm square plus 2hm plus a is equals to 0. And this is the equation number 2. Equation 2 is called the auxiliary equation of the equation 1. That is ax square plus 2hxy plus by square is equals to 0. Roots of equation 2 are the slopes of the lines represented by the equation, that is ax square plus 2hxy plus by square is equals to 0. Now the solve example. Show that the lines represented by the equation x square minus 2xy minus 3y square is equals to 0 are the distinct. Now see this line. The comparing this equation x square minus 2hxy minus 3y square is equals to 0 with ax square plus 2hxy plus by square is equals to 0. If we compare then what is the value of a? A is 1 and the h is minus 1. B is a minus 3. Here h square minus ab is equals to 0. Minus 1 bracket square minus 1 into minus 3. 1 plus 3, that is equals to 4, which is the positive. As h square minus ab is greater than 0, the lines represented by the equation x square minus 2xy minus 3y square is equals to 0 are distinct. Now the next, show that the lines represented by the equation x square minus 6xy plus 9y square is equals to 0 are the coincident. Now comparing the equation, again x square minus 6xy plus 9y square is equals to 0 with ax square plus 2hxy plus by square is equals to 0. We get the a is equals to 1, then h is equals to minus 3, b is equals to 9. Again the h square minus ab, that is a minus 3 square minus 1 into 9. Then you will get 9 minus 9, and that's equals to 0. Here h square minus ab is equals to 0, as the h square minus ab is equals to 0, then lines represented by the equation x square minus 6xy plus 9y square is equals to 0 are coincident. Next, find the sum and the product of the slopes of the lines represented by x square plus 4xy minus 7y square is equals to 0. Now again the comparing the equation x square plus 4xy minus 7y square is equals to 0 with ax square plus 2hxy plus by square is equals to 0. Then here you will get a is equals to 1, h is equals to 2, b is equals to minus 7. If m1 and m2 are the slopes of the lines represented by this equation, then sum of the slopes, that is m1 plus m2 is equals to minus 2h upon b, and the product of the slope is a upon b by the formula. And here you will have, that is a minus 2h. Here is a minus 4, the value of 2 into h, that is a 2 into 2, that will become 4. That is a minus 4 upon minus 7. The value of b is a minus 7, and this will minus and minus, the minus divided by minus, and that will become plus. Therefore m1 plus m2 is equals to 4 upon 7. m1 into m2 is equals to, the value of a is a 1 and the b is a minus 7, and m1 into m2 is equals to minus 1 upon 7. Therefore their sum is 4 by 7 and the product is a minus 1 by 7. Find the separate equations of the lines represented by x square minus 4y square is equals to 0. Now we can write this, that is x minus 4y square, that is in first bracket, that is x square minus 2y bracket square, and then in first bracket you will get x minus 2y, in second bracket you will get x plus 2y is equals to 0. Therefore, required separate equations are x minus 2y is equals to 0 and x plus 2y is equals to 0. Next, 3x square minus 7xy plus 4y square is equals to 0. Again, the product of first and last term is 12. Then what will be the two terms? That is a minus 3 and minus 4. Therefore, it's 3x square minus 3xy minus 4y square plus 4y square is equals to 0. Now from this we will take the common 3x, then in bracket x minus y, and from this you can take as a common 4y, then in bracket you will get x minus y. Again the take x minus y as a common, then in bracket you will get 3x minus 4y is equals to 0. Therefore the required separate equations are x minus y is equals to 0 and 3x minus 4y is equals to 0. Next equation is x square plus 2xy minus y square is equals to 0. Can we factorize this? Okay. Therefore, the corresponding its auxiliary equation is, that is bm square plus 2hm plus a is equals to 0. Here we cannot factorize these equations, and for that we will convert this into the auxiliary equations, and here you will get the minus m square plus 2m plus 1 is equals to 0. Because the value of b is a minus 1, okay, 2hm, okay, the value of h is 1, therefore it is a 2m, and the last is plus a is equals to 0. Therefore minus m square plus 2m plus 1 is equals to 0, and hence m square minus 2m minus 1 is equals to 0. And now here by using the formula, that is what is that formula that you have learned in the 10th standard? Here is a ax square plus bx plus c is equals to 0. Then x is equals to minus b plus or minus in root of b square minus 4ac upon 2a. The value of b is here minus 2. Minus in bracket minus 2, that is a plus 2. Plus or minus in root of b square means what? 2 square means 4. Minus 4ac, that is a 4 plus 4, it will become 8. Now this 8 can be factorized as 4 into 2. The square root of 4 is a 2. And take the 2 as a common, then you will get m is equals to 1 plus or minus root 2. And these are the slopes of the lines. Therefore, the slope of these lines are m1 is equals to 1 plus root 2 and m2 is equals to 1 minus root 2. And therefore, the required separate equations are y is equals to m1x and y is equals to m2x, and the substitute the value of m, that is y is equals to in bracket 1 plus root 2 bracket complete into x, and y is equals to in bracket 1 minus root 2 bracket complete into x. And this step we follow when we cannot factorize this. We cannot factorize at that time. Convert this into auxiliary equation, find out the value of m, and equation of the separate lines are in this form because the given line passes through the origin. Okay. Now the next is 5x square minus 3y square is equals to 0. Now 5x square is a square of root 5x bracket square minus root 3y bracket square, and therefore you will get root 5x minus root 3y bracket complete root 5x plus root 3y is equals to 0. Therefore the required separate equations are root 5x minus root 3y is equals to 0 and root 5x plus root 3y is equals to 0. Next, find the value of k if 2x plus y is equals to 0 is one of the lines represented by 3x square plus kxy plus 2y square is equals to 0. That is, this is the joint equation of the two lines. Out of this, one line is this. Then find the value of the k. For that, the slope of this line, which is the line? That is the 2x plus y. The slope of this line, here is we can write in this form, that is the y is equals to mx. Okay, therefore here we can write this equation, y is equals to minus 2x, and then the slope of the line is minus 2. As a 2x plus y is equals to 0 is one of the lines represented by 3x square plus kxy plus 2y square is equals to 0. It's one of the line, its slope is a minus 2. What about its auxiliary equation? Now convert this equation into auxiliary equation. How it is converted? That is divide this whole equation by x square, and then you will get that is a, you will get the auxiliary equation which is of the form, that is a bm square plus 2hm plus a is equals to 0. The value of a is here 2, okay, and the next is a 2hm, okay, the value of that 2h is a k, and plus a, the value of a is a 3 here. If we compare it, substitute the value of, that is a b, h and a, and if we substitute the value of m, which is the one root of that auxiliary equation, substitute that m is minus 2, that is a 2 minus 2 bracket square plus k in bracket minus 2, value of the m plus 3, and if we simplify, minus 2 square, that is a 4, 4 into 2, that is 8, k into minus 2k plus 3 is equals to 0. Therefore minus 2k, 8 plus 3 is 11, and that's why here we will have, that is a 2k is equals to 11 and k is equals to 11 upon 2. You can apply here the alternate method also. Okay. Now next, find the condition that the line 3x minus 2y is equals to 0 coincides with one of the lines represented by ax square plus 2hxy plus by square is equals to 0. It coincides with one of the line. The corresponding auxiliary equation is, what is that? Bm square plus 2hm plus a is equals to 0. As the line 3x minus 2y is equals to 0 coincides with one of the lines given by ax square plus 2hxy plus by square is equals to 0. Its a slope is, what is the slope of this line? That is a, we have this line, which is that 3x minus 2y is equals to 0. Therefore 2y is equals to 3x, and hence y is equals to 3 by 2x. This is the slope of the line. Therefore the value of m is a 3 by 2 is the root of the auxiliary equation. And if we substitute this value of m in its auxiliary equation, which is the bm square plus 2hm plus a is equals to 0. Substitute m is equals to 3 by 2 plus 2h 3 by 2 into a, and then simplify this. The square of 3 by 2 is a 9 by 4 into b plus 2 to get cancelled, you will get 3h plus a is equals to 0, and multiply the whole equation by 4. Then you will get, that is a 4a plus 12h plus 9b is equals to 0 is the required condition. Find the combined equation of the pair of lines passing through origin, okay, and perpendicular to the lines represented by 3x square plus 2xy minus y square is equals to 0. Now see this here. What is the concept of this problem? This is the coordinate geometry, that is x-axis and the y-axis. Okay, and here suppose that these are the our lines, okay, and these are the our given lines, and I will write here these lines are L1 and this is the L2. This is joint equation. We want to find out the combined equation of the lines, that lines which are perpendicular to these lines, which are perpendicular to this line. And suppose that I will draw that two lines, and suppose that this is the small l, okay, this is the small L1 which is perpendicular to this capital L1. Next is another line which is the small L2 which is perpendicular to capital L2. Then we want to find out the combined equation of the small L1 and the small L2. Now see this, how to find out it. Let M1 and M2 are the slopes of the lines represented by, that is a 3x square plus 2y minus y square is equals to 0. Now can we factorize this? That is, we can factorize it. Okay. Which are the two required lines? These blue color lines. We want to find out the joint equation of these two lines which are perpendicular to our given lines. Okay. Now the sum of the roots m1 plus m2 is equals to minus 2h upon b. The value of h is 1. Okay. and therefore h is 1 and b is a minus 1. That is minus 2 upon minus 1, that is equals to 2. Products of the roots, that is m1 into m2 is equals to a upon m1 into m2 is equals to a upon b. The value of a is 3, b is a minus 1, and overall you will get minus 3. Now the required lines are perpendicular to the given lines, our required lines. These blue colors, these are my required lines. They are perpendicular to given lines. L1 and L2 are my given lines, which is in the form of the joint equation. And therefore, their slopes will be minus and reciprocal, okay, and the required lines pass through the origin. Therefore, its equation will be in this form, which is form y is equals to mx. Therefore, the equation y is equals to minus 1 upon m1x and y is equals to minus 1 upon m2, here is a m2x. Okay, and therefore we can form this, that is m1y is equals to minus x, m2y is equals to again the minus x. Therefore x plus m1y and x plus m2y is equals to 0. Their combined equation is in first bracket x plus m1y, in second bracket x plus m2y is equals to 0. Now the product x into x, you will get x square, x into m2y and x into m1y. Take xy as a common, then in bracket you will get m1 plus m2 bracket completed into xy, and the product of these two, m1 into m2 into y square, and that's equals to 0. Now what is the value of m1 plus m2? We know the value of m1 plus m2 is 2 and m1 into m2 is minus 3. Substitute here, m1 plus m2 is 2, m1 into m2 is minus 3, and hence you will get the joint equation of that two lines which are in blue ink. They are perpendicular to our lines, and this is the joint equation, which is the x square plus 2xy minus 3y square is equals to 0. Now the next problem. Find the value of k if the slope of one of the line represented by 4x square plus kxy plus y square is equals to 0 is 4 times the slope of the other lines. Now here we have given the condition. Let the slope of the lines represented by 4x square plus kxy plus y square is equals to 0 be m and 4m. Okay, the slope of one line is a 4 times the other. Suppose the slope of the first line is m, then what will the slope of the other line? It's a 4m. Okay, and what about their sum of the slopes? M plus 4m is 5m. But the sum of the slope from this equation, what is that? Minus 2h upon b. What is the value of here? The value of h, which is here. If you compare here, that is we have always here the 2h x y, and if we compare the value of 2h is a k. Here is the value of this 2h is equals to k, and therefore here the substitution, but here minus sign, that is a minus k upon 1, which is a minus k, and therefore here the sum of the roots we know, that is a m1 plus m2 is 5m. Therefore the value of 5m is a minus k, and therefore m is equals to minus k upon 5. See this again, I will repeat here. That is x square plus kxy plus y square is equals to 0. The middle term is a 2hxy. Therefore the value of 2h is a k, and the sum of the roots is minus 2h upon b. The value of 2h is a k upon 1, which is minus k. Therefore 5m is equals to minus k. Therefore m is equals to minus k by 5, and this is the first. Now their product, m1 into m2, that is m into 4m, that is 4m square. What is their product? A upon b. A upon b, the value of a is a 4 and b is 1. 4 upon 1, a upon b is equals to 4. And therefore here you will have 4m square is equals to 4. Products of the roots, 4m square. Okay, but the value of products of the roots, that is here I will write again a upon b. But a upon b is value of a is 1, b is a is 4, b is 1, and therefore overall you will get, therefore 4m square is equals to 4. 4m square is equals to 4. Therefore, m square is equals to 1. This is the equation number 2. What about the from equation 1 and equation 2? Here is this is the equation number 1, that is m is equals to minus k by 5, and hence it is a value of m square minus 1. M square is equals to 1, but the value of m, what is the value of m? Here is the value of m. M is equals to minus k upon 5. If we substitute minus k by 5 bracket square is equals to 1 and squaring, then you will get k square is equals to 25, and hence k is equals to plus or minus 5. And in this way we have completed here all the solved example and the theoretical part. Now we'll start the exercise 4.1. Very simple questions. Find the combined equation of the lines of the following pair of the lines. 2x plus y is equals to 0, 3x minus y is equals to 0. Combined equation of the lines 2x plus y is equals to 0 and 3x minus y is equals to 0. That is the product of these two lines. In first bracket 2x plus y, into second bracket 3x minus y is equals to 0. 2x into 3x, that is 6x square. 2x into minus y, minus 2xy. Y into 3x plus 3xy, minus y into plus y, minus y square. And if you simplify this, then you will get 6x square plus, therefore the combined equation is a 6x square plus xy minus y square. Next is x plus 2y minus 1 is equals to 0 and x minus 3y plus 2 is equals to 0. Again the combined equation, that is the product of these two lines. X plus 2y minus 1 is equals to 0 and x minus 3y plus 2 is equals to 0. You can perform the product of these two lines. In first bracket x plus 2y minus 1 into second bracket x minus 3y plus 2 is equals to 0. That is x into x, you will get x square, x into minus 3y minus 3xy. Next is a x into these two, then you will get 2x. 2y into x, that is a 2 plus 2xy. Next is a 2y into minus 3y, that is a minus 6y square. 2y into plus 2, that is a 4y. Minus 1 into x, minus x. Minus 1 into minus 3, that is a plus 3y and the minus 2, and that's equals to 0. Therefore x square minus 3xy plus 2xy, that is you will get minus xy. Next is a minus 6y square. Plus 2x minus x, you will get x. Next is a 3y plus 4y, 7y. And what about the constant? Constant is a minus 2 is equals to 0. Next, find the combined equation of the lines passing through the point 2, 3 and parallel to the coordinate axis. Okay. Now what is here? Suppose that this is the coordinate system. Okay. This is the x-axis and here is the y-axis. This is the point, that is a 2, 3. Here is the point 2, 3. 2 and 3. The line passes through this point. My lines are, these are my lines. This is the first line which passes through this point. This is the first line. And what about the second line? This is the second line. Now the equation of the line which is parallel to x-axis is y is equals to 3. And the equation of the line which is parallel to y-axis is x is equals to 2. And now their joint equation. Equation of the coordinate axis are x is equals to 0 and y is equals to 0. Equation of the lines passing through the 2, 3 are parallel to the coordinate axis are x is equals to 2 and y is equals to 3. That is x minus 2 is equals to 0 and y minus 3 is equals to 0. And their combined equation, that is x minus 2 into y minus 3, that's equals to 0. The product is very easy, x into x. Okay, x into x, that is x into y is xy. X into minus 3, minus 3x. Minus 2 into y, minus 2y, minus 2 into minus 3. That is a plus 6. And therefore, xy minus 3x minus 2y plus 6 is equals to 0. This is the required joint equation. Next, find the combined equation of the lines which are passes through the point 2, 3 and perpendicular to the lines, and these are the, which is the 3x plus 2y minus 1 is equals to 0. X minus 2y, x minus 3y plus 2 is equals to 0. Our required lines are perpendicular to these lines. Therefore, the slope of that lines are minus and reciprocal of these lines. Now let L1 and L2 be the lines passing through this 2 and 3 and perpendicular to these lines. Our lines are perpendicular to them. Now we want to find out the slope of the line. We'll express this in the form of very important form, that is a slope intercept form. Y is equals to mx plus c, and we have expressed this, that is a y is equals to minus 3 by 2x plus 1 by 3. How to express this? Now see this here. This is the 3x plus 2y minus 1. Keep this 2y on the left hand side and another terms to the right hand side, which is the minus 3x and plus 1, and that's why y is equals to minus 3 by 2x plus 1 upon 2. The slope of the line is minus 3 by 2. Similarly, we can find out the slope of the other line. Y is equals to 1 by 3x plus 2 by 3, and therefore the slope of the lines are minus 3 by 2 and 1 by 3 respectively. The slope of the lines L1 and L2 are required lines because that lines are perpendicular to these lines. Therefore, their slopes are minus and reciprocal. Therefore, the minus and reciprocal of this is a 2 by 3 and it will become plus. Reciprocal of 1 by 3 is 3 and minus is minus 3. Okay. Therefore, the slope of the lines are 2 by 3 and minus 3. Since the lines passes through this point, that is a 2, 3, here we will apply the form, that is a slope point form. Y minus y1 is equals to m in bracket x minus x1, and here y minus 3 is equals to 2 by 3 in bracket x minus 2, and y minus 3 is equals to minus 3 in bracket x minus 2. And if we simplify it, multiply this whole equation by 3, then you will get 3y minus 9 2x minus 4. Again simplify this, y minus 3 is equals to minus 3x plus 6, and if we simplify this again, you will get 2x minus 3y minus 9 will become plus here, that is minus 4 plus 9, you will get 5. Therefore 2x minus 3y plus 5 is equals to 0, and another line is a 3x plus y minus 9 is equals to 0. Now their combined equation, that is a 2x minus 3y plus 5 in first bracket and second bracket 3x plus y minus 9 is equals to 0. Now the combined equation, 2x into 3x, you will get 6x square, 2x into y, you will get plus 2xy, 2x into minus 9, that is a minus 18x. Next is the minus 3 into 3x, you will get minus 9xy, minus 3y into y, minus 3y square, minus 3y into minus 9 plus 27y. Okay, 5 into 3x, 15x, 5 into 3y, 5 into y, you will get 5y, 5 into minus 9 minus 45, and overall you will get 6x square, 2xy, again xy, minus 9xy, you will get minus 7xy, here is a minus 7xy, minus 3y square. What about the next? The terms of the x, here is a minus 18x plus 15x, you will get minus 3x. And what about the y? Plus 5y plus 27y is equals to 32y, and last is a constant, minus 45 is as it is, and therefore their joint equation is a 6x square minus 7xy minus 3y square minus 3x plus 32y minus 45 is equals to 0. Next is a find the combined equation of a line which passes through the point minus 1 and 2, and they are parallel to these lines. Which are the lines? X plus 3y minus 1 is equals to 0, and the other is perpendicular to this line. Means we will find out the slope of this line as it is. For this line, we will take its a minus and reciprocal. That will be the slope of our required lines. Okay, let L1 be the line passes through the point minus 1 and 2. Okay, now the slope of the line x plus 3y minus 2. How to find out the slope of this line? We can write here. What is that? X, here that is a 3y is equals to, bring this term to the right hand side, that is a minus x and plus 1, and therefore here y is equals to, divide the whole equation by 3, then you will get minus 1 by 3x plus 1 by 3. Therefore the slope of the line is minus 1 by 3. Slope of the line L1 is minus 1 by 3. Therefore the equation of the line L1 is, as it passes through the point minus 1 and 2, therefore y minus y1 is equals to m in bracket x minus x1, and therefore that minus 1 will become plus 1 here. Y minus 2 is equals to minus 1 by 3 in bracket x plus 1, and then simplify, multiply this whole equation by 3, then you will get 3y minus 6 is equals to minus x and minus 1, and after simplification here you will get x plus 3y minus 5 is equals to 0. Now let L2 be the line passes through this point. Now this line is perpendicular to this line. Again the slope of the line. Instead of finding in this way, you can find out in the form y is equals to mx plus c. I will always suggest this. Now how to write this? Here is a 2x minus 1 is equals to 3y, and therefore divide the whole equation by 3, and it can be written as 2 upon 3x minus 1 by 3. Therefore the slope of this line is 2 by 3. But our required line is perpendicular to this line, and therefore its slope will be minus and reciprocal of this, which is the 3 by 2. Okay, therefore the slope of the line L2 is a minus 3 by 2. Again the equation in the slope point form, which is y minus y1 is equals to m in bracket x minus x1, that is y minus 2 minus 3 by 2 in bracket x plus 1, and if we multiply this whole equation by 2, then you will get 2y minus 4 minus 3x and minus 3, and again simplification, you will get 3x plus 2y, and here is a minus 4. If we bring this minus 3 to the left hand side, it will become plus 3. Minus 4 plus 3 is a minus 1, and that's equals to 0. Therefore 3x plus 2y minus 1 is equals to 0. Hence the equations of the required lines are x plus 3y minus 5 is equals to 0 and 3x plus 2y minus 1 is equals to 0. Their combined equation is, in first bracket x plus 3y minus 5, in second bracket is 3x plus 2y minus 1 is equals to 0. Now the product. Now here x into 3x, that is 3x square, x into 2y plus 2xy, x into minus 1 minus x, 3y into 3x plus 9xy, 3y into plus 2y, then you will get 6y square, 3y into minus 1 minus 3y, minus 5 into 3x minus 15x, minus 5 into 2y, then you get minus 10y, minus 5 into minus 1 plus 5, and that's equals to 0. Now the simplification. Here is a 3x square. The terms of here is a 2xy, 9xy. It will become 11xy. Next is a 6y square as it is. The terms of x, minus 15, minus 16x. Next is a minus 10y, minus 3y, minus 13y. And the last, the constant 5 as it is. Now the question number 2. Find the separate equation of the lines represented by the following equation. Here is a 3y square plus 7xy is equals to 0. I am writing here equals to 0. Now from this equation we can take as a y as a common. Then in bracket you will get y in bracket 3y plus 7x is equals to 0. The separate equations are y is equals to 0 and 7x plus 3y is equals to 0. Next is a 5x square minus 9y square is equals to 0. 5x square is a square of root of 5x bracket square. 9y square is a 3y bracket square. In first bracket you will get root 5x plus 3y. In second bracket you will get root 5x minus 3y, that's equals to 0. And therefore their separate equations are root 5x plus 3y is equals to 0 and root 5x minus 3y is equals to 0. Very simple. X square minus 4xy is equals to 0. Again, x square minus 4xy is equals to 0, you can take x as a common. Then in bracket you will get x minus 4y is equals to 0. The separate equations are x is equals to 0 and x minus 4y is equals to 0. Next is 3x square minus 10xy minus 8y square is equals to 0. Now we can factorize this. That is a 3 into 8, that is a 24. And minus 12xy plus 2xy, these are the factors. Now we can write it 3x square minus 12xy plus 2xy minus 8y square is equals to 0. From the first two terms you can take 3x as a common. Then in bracket you will get x minus 4y. From these two terms you can take 2y as a common. Then in bracket you will get x minus 4y is equals to 0. Again take the x minus 4y common. Then what are the remaining terms? 3x plus 2y is equals to 0. Therefore the separate equations are x minus 4y is equals to 0 and 3x plus 2y is equals to 0. Now the next is 3x square minus 2 root 3xy minus 3y square is equals to 0. Now the product of the first and last term. What is the product of first and last term? It is a minus 9. And the middle term is a minus 2 root 3. What are the two terms whose sum is a minus 2 root 3 and the product is a minus 9? The terms are, that is a minus 3 root 3 and the another term is a root 3. The sum of these two terms, that is a minus 3 root 3 plus root 3 is minus root 3, and the product of these two, that is a minus 3 root 3 into root 3 is a 3. Root 3 into root 3 is a 3. 3 into 3 9, which is the minus 9. And hence that is a 3x square minus 3 root 3xy plus root 3xy minus 3y square is equals to 0. Now from these two we can take the common as a 3x. Then in bracket you will get x minus root 3y. What about here? This 3 can be written as, that is a 3 is equals to root 3 into root 3. And from this you can take root 3 as a common and root 3y. Then in bracket you will get x minus root 3y is equals to 0. And therefore x minus root 3y in first bracket, second bracket is a 3x plus root 3y is equals to 0. And that's why their separate equations of the lines are x minus root 3y is equals to 0 and 3x plus root 3y is equals to 0. Now the next problem. X square plus 2 cosec alpha bracket complete into xy plus y square is equals to 0. Now here x square plus 2 cosec alpha into xy plus y square is equals to 0 can be written as, that is y square plus 2 cosec alpha into xy plus x square is equals to 0. Divide the whole equation by x square. Then you will get y upon x bracket square plus 2 cosec alpha y upon x plus y x square upon x square is 1. And hence again this is the quadratic equation in the form, that is a ax square plus bx plus c. Here we are applying the formula. What is that formula? X is equals to minus b plus or minus in root of b square minus 4ac. What is here actually x is y upon x minus b, that is this is the term minus 2 cosec alpha plus or minus in root of b square means what? Cosec alpha bracket square means what? 4 cosec square alpha minus 4 ac. The coefficient of here is 1, c is 1, therefore it is a minus 4 into 1 into 1 upon 2 into 1, and overall you will get minus 2 cosec alpha plus or minus, again here is a 4 and 4. Take 4 as common, square root of 4 is 2, that is a plus or minus 2 in root of cosec square alpha minus 1. The value of cosec square alpha minus 1 is a cot square alpha and its a square root is a cot alpha. Therefore y upon x is equals to minus cosec alpha plus or minus cot alpha, and once you take it's a plus sign and here you are taking the minus sign. Now how it is? Suppose that y upon x is equals to, if we take plus sign, then you will get here, that is a cot alpha minus cosec alpha, because it is a already, here is a cosec alpha. This is the first one. What about here? If you take the negative sign, then here you will get y upon x is equals to, take minus sign common, and then you will get minus, here is a cosec alpha plus cot alpha. Okay, and here y upon x is equals to cot alpha minus cosec alpha, and y upon x is equals to minus cosec alpha plus cot alpha. These are the separate equation. If we simplify it, that is y is equals to, if we multiply it with, that is y is equals to cot alpha minus cosec alpha into x. Okay, and it can be written as, that is the cosec alpha plus cot alpha bracket complete into x minus y, and from this equation you will get the another, which is the cosec alpha minus cot alpha into x plus y is equals to 0. These are the equations. Next is a x square plus 2xy into tan alpha minus y square is equals to 0. Again here, x square plus 2 tan alpha into xy minus y square is equals to 0 can be written as, that is a minus, multiplied minus 1 on both sides. You will get y square minus 2 tan alpha into xy minus x square is equals to 0. Divide the whole equation by x square. Then here you will get y upon x minus 2 tan alpha into y upon x minus 1 is equals to 0. Now here y upon x, again it's a solution. That is y upon x is the root of this quadratic equation, which is first minus b. But what is here b? B is a minus 2 tan alpha. Here is a minus 2 tan alpha minus b. Here is a minus, that will become plus, that is a 2 tan alpha. Plus or minus in root of b square means what? 2 tan alpha bracket square, that is a 4 tan square alpha. Minus 4ac, 4, a is 1, c is minus 1. Plus 1 and minus 1, that will become again the, here is a plus 4. That is, you can write here, that is a y upon x is equals to, you will get 2 times tan alpha. Okay, and plus or minus, from here you will get, that is a 4 tan square alpha plus 4. Take 4 as common and it will become 2. Square root of 4 is 2. Therefore here y upon x is equals to 2 tan alpha plus or minus 2 in root of tan square alpha plus 1 upon 2. Again here that same step is repeated here. That is, we can write here 2 get cancelled. If you take the 2 as common, then here you will get y upon x tan alpha plus tan square alpha plus 1 is a sec square alpha, and it's a square root of sec alpha. Once you take the plus sign and another is a minus. Therefore y upon x is equals to tan alpha plus sec alpha, and y upon x is equals to tan alpha minus sec alpha. And therefore the separate equations of the lines are, that is a, after simplification you will get, that is a sec alpha minus tan alpha into x plus y, and sec alpha plus tan alpha bracket complete into x minus y, and that's equals to 0. Now the next, find the combined equation of a pair of lines passing through the origin and perpendicular to the lines represented by the following equation. Now here the first equation, 5x square minus 8xy plus 3y square is equals to 0. Comparing it with ax square plus 2hxy plus by square is equals to 0. The value of a is 5. Next is a 2h is minus 8, b is 3, and here m1 and m2 be the slopes of the lines represented by 5x square minus 8xy plus 3y square is equals to 0. Sum of the roots m1 plus m2 is equals to minus 2h upon b, and it is 8 upon 3. Okay, the value of 2h is minus 8 and b is 3. Minus and minus, that will become plus. Therefore m1 plus m2, that is equals to, here is a minus in bracket minus 8 upon 3, and that will become plus here. A upon b, m1 into m2 is a upon b. The value of a is 5 and b is 3. Therefore m1 into m2 is 5 by 3. Now required lines are perpendicular to these lines, and their slopes are minus and reciprocal. That is minus 1 upon m1 and minus 1 upon m2. Since these lines passing through the origin, their separate equations is y is equals to minus 1 upon m1x and y is equals to minus 1 upon m2x. And therefore these lines can be written as m1y is equals to minus x and m2y is equals to also minus x. Therefore x plus m1y is equals to 0 and x plus m2y is equals to 0. Their combined equation x plus m1y into x plus m2y is equals to 0. Their joint equation product is first is x into x square, next is x into m2y, x into m1y, take xy as a common, then you will get here m1 plus m2 into xy and the product of m1y into m2y. Therefore you will get m1 into m2y square is equals to 0. Now what is the sum of the slopes? m1 plus m2 we have calculated is 8 upon 3 and product is 5 by 3. Therefore here is x square plus 8 upon 3xy plus 5 by 3 y square is equals to 0. Multiply the whole equation by 3 and then you will get 3x square plus 8xy plus 5y square is equals to 0. Now the next is, that is 5x square plus 2xy minus 3y square is equals to 0. Find the combined equation of the lines which are perpendicular to these two lines. Okay. Now again the comparing 5x square plus 2xy minus 3y square is equals to 0 with ax square plus 2hxy plus by square is equals to 0. Here the value of a is 5, 2h is 2, b is minus 3. Let m1 and m2 be the slopes of the lines represented by 5x square plus 2xy minus 3y square is equals to 0. Sum of the slopes m1 plus m2 is equals to minus 2h upon b. Again the value of 2h is 2, therefore it is a minus 2 by minus 2 and b is a minus 3 and this minus and minus that will become plus. Therefore m1 plus m2 is 2 by 3. m1 into m2 is a upon b. The value of a is 5 and b is a minus 3. Overall you will get m1 into m2 is a minus 5 by 3. Now the required lines are perpendicular to this line. Therefore the slope of our lines is minus 1 upon m1 and minus 1 upon m2. Since again the lines are passes through the origin and their separate equations are y is equals to minus 1 upon m1x and y is equals to minus 1 upon m2x, and therefore the equations can be written as m1y is equals to minus x and m2y is equals to again minus x, and therefore the lines are x plus m1y is equals to 0 and x plus m2y is equals to 0. Again their joint equation, combined equation, x plus m1y in first bracket, x plus m2y in second bracket, and their product x into x, x square, x into m2y and x into m1y. Take xy as a common, then in bracket you will get m1 plus m2, bracket complete into xy plus m1 m2 into y square is equals to 0. Again the m1 plus m2 is 2 by 3 xy, m1 into m2 minus 5 by 3 y square is equals to 0. Multiply the whole equation by 3 and then you will get 3x square plus 2xy minus 5 square is equals to 0. This is the required joint equation. Next third is xy plus y square is equals to 0. Comparing this equation with ax square plus 2hxy plus by square is equals to 0. Now here the value of a is 0, h is 2h is 1 and b is 1. Therefore consider the equation xy plus y square is equals to 0. Take y as common. Then here you will get the separate equation y is equals to 0 and x plus y is equals to 0. Let m1 and m2 be the slopes of this line. The slope of the first line as y is equals to, it's a 0. Therefore the y is equals to 0 means what? It is the x-axis. What is the equation of the x-axis? Equation of the x-axis is y is equals to 0. Therefore as m1 is 0, okay, y is equals to 0 means what? It is x-axis. Therefore its slope is 0. And here x plus y is equals to 0. Therefore what you will get the slope of the another line? Slope of the y is equals to minus x. Therefore the slope of the another line is m2 is minus 1. Now the required lines are the perpendicular to this line. Now the for the first line is the x-axis. It's a perpendicular another line which is the y-axis, and its equation is x is equals to 0. Therefore, this is very important. Okay. Since the m1 is equals to 0, therefore it's a minus and reciprocal does not exist. It means that that is nothing but the y-axis, and the equation of the y-axis is x is equals to 0. And second is easy, that m2 is equals to minus 1, and it's a minus and reciprocal, it's a plus 1. It's a no problem. Since these lines passes through the origin, they are separate equation. Equation of the first line is x is equals to 0. Because it is a y-axis, its equation is x is equals to 0. And equation of the another line, which is that y is equals to mx. The value of m is 1, which is y is equals to x. And therefore, it is a x minus y is equals to 0. Therefore, their joint equation is a x into in bracket x minus y is equals to 0. And therefore, the joint equation is a x square minus xy is equals to 0. Now, the next is 3x square minus 4xy is equals to 0. Now again take x as a common. Then their separate equations are x is equals to 0. 3x minus 4y is equals to 0. Let m1 and m2 be the slopes of these lines. The slope of the line as x is equals to 0. X is equals to 0 is nothing but the y-axis. This is the y-axis, and therefore it does not exist. Slope of that axis does not exist. Okay. M1 does not exist. M2 is a 3 by 4. No problem. The slope of this line. What is that? It is we can find out it. 3x is equals to 4y. Therefore, y is equals to 3 by 4x. This is the slope of this line, which is the 3 by 4. Slope of the another line. Now, the required lines are perpendicular to this line. Okay. Therefore, their slopes are minus and their reciprocal. That is minus 1 upon m1 and minus 1 upon m2. As m1 does not exist, therefore it's a minus and reciprocal is 0. And therefore, its slope is 0. Therefore, the required our next line will be x-axis. Okay, x is equals to 0. Now see this here. This m1 does not exist. Therefore, it's a minus and reciprocal is equals to 0. m2 is a 3 by 4, and therefore it's a minus and reciprocal is a minus 1 upon m2 is a minus 4 by 3. Since these lines are passes through the origin and their separate equations are. Now, what is the equation of this x-axis? Equation of x-axis is a y is equals to 0, and equation of this line, which is again y is equals to mx, y is equals to minus 4 by 3x, and if we simplify this, then you will get 4x plus 3y is equals to 0 and y is equals to 0. Again, they are joint equation. That is y in bracket 4x plus 3y is equals to 0. And if we perform the product, then you will get 4xy plus 3y square is equals to 0. Okay. And in this way, this is our required joint equation. Now we'll start the question number 4. Find k if sum of the slopes of lines represented by x square plus kxy minus 3y square is equals to 0 is twice their product. That is, m1 plus m2 is equals to 2 times, here is a condition, I will write here m1 plus m2, m1 plus m2 is equals to m1 plus m2 is equals to 2 times m1 into m1 into m2. Now here, comparing the equation x square plus kxy minus 3y square is equals to 0 with ax square plus 2hxy plus by square is equals to 0. The value of a is 1, 2h is k, and b is minus 3. Let m1 and m2 be the slopes of the lines represented by x square plus kxy minus 3y square is equals to 0. Sum of the rows, that is m1 plus m2, that is equals to minus 2h upon b. The value of 2h is a k, and that's why it is a minus k, and b is a minus 3. This minus and minus, that will become plus. Therefore, m1 plus m2 is equals to k upon 3. Next is the product of the roots. That is m1 into m2 is equals to a upon b. The value of a is 1 and b is minus 3. And therefore, here you will get m1 into m2 is equals to minus 3. We have given the condition that m1 plus m2 is equals to 2 times m1 into m2. Now substitute the value of m1 plus m2, which is k upon 3, and m1 into m2 is a minus 1 by 3. And if we simplify it, what is that? That is a k upon 3 is equals to minus 2 by 3. 3 get cancelled on both sides and you will get the value of k is equals to minus 2. Next problem. Slopes of the lines represented by 3x square plus kxy minus y square is equals to 0 differ by 4. Find the value of k. Their slopes are differ by 4 means what? You have given the value m1 minus m2 and that is equals to 4. Comparing the equation 3x square plus kxy minus y square is equals to 0 with ax square plus 2hxy plus by square is equals to 0. We get a is equals to 3, b is equals to 2h is equals to k and b is equals to minus 1. Let m1 and m2 be the slopes of the lines represented by 3x square plus axy minus y square is equals to 0. Again the slope of, that is the sum of the slopes, that m1 plus m2 is equals to minus 2h upon b, which is the value of 2h is equals to k. That is a minus k upon b is a minus 1. Minus k upon minus 1, which is the plus k. And m1 into m2 is equals to a upon b. The value of a is 3 and b is minus 1. Therefore, a upon b is equals to minus 3. Now we know that from our 10th standard, we know this type of the formulas. That m1 minus m2 bracket square is equals to m1 plus m2 bracket square minus 4 times m1 into m2. What is the m1 plus m2? It's a k. That is a sum. m1 plus m2 is equals to k. And substitute the values. m1 into m2, that is a minus 3. Here is a minus 3. And if we simplify this, then you will get k square plus 12. m1 minus m2 bracket square is equals to k square plus 12. We have given that the difference of their slopes is 4. Differ by slope 4, but their slopes are differ by 4. Therefore, m1 mod of m1 minus m2 is 4. Squaring on both sides, then you will get m1 minus m2 bracket square is equals to 16. And therefore, this is the 2 and this is the 1. Therefore, m1 minus m2 bracket square is equals to 16. And if we write it, k square plus 12 is equals to 16. Therefore, k square is equals to, then here you will get 16 minus 12. Therefore, k square is equals to 4 and k is equals to plus or minus 2. Next question. Slope of one of the line given by kx square plus 4xy plus, here is a minus sign, minus y square is equals to 0 exceeds the slope of the other by 8. Now again the comparing the equation kx square plus 4xy minus y square is equals to 0 with ax square plus 2hxy plus by square is equals to 0. Here a is equals to k, 2h is equals to 4, b is equals to minus 1. Let m1 and m2 be the slopes of the lines represented by kx square plus 4xy minus y square is equals to 0. Therefore, the sum of the slopes m1 plus m2 is equals to minus 2h upon b. The value of, here is a 2h is a 4. Okay, the value of 2h is a 4. Therefore, it is a minus sign. And that's why it is a minus 4 and b is equals to minus 1. Therefore, minus 4 upon minus 1 and that is a plus 4. Therefore, m1 plus m2 is equals to 4. What about their product? m1 into m2 is equals to a upon b. The value of a is k and b is minus 1. And therefore, m1 into m2 is equals to minus k. We are given that the m2 is equals to m1 plus 8. Now see, this is the question. What is that? The slope of one of the lines given by kx square plus 4xy minus y square is equals to 0 exceeds the slope of the other by 8, and hence we are writing here that is a m2 is equals to m1 plus 8. Now substitute the value. What we have given, m1 plus m2 is equals to 4, but m2 is m1 plus 8, and therefore m1 plus m1 plus 8 is equals to 4. Therefore 2m1 is equals to minus 4 and m1 is equals to minus 2. Also their product, that is m1 into m2. What is here? This is the m1 into m2. m1 into m2 is equals to minus k. But what is the m2? m2 is m1 plus 8, and their product, m1 is minus 2. m1 plus 8 is again m1 is minus 2 plus 8, and that is equals to minus k. And here minus 2 plus 8, that is a 6. 6 into minus 2, minus 12 is equals to minus k, and hence k is equals to 12. Next question. Find the condition that the line 4x plus 5y is equals to 0 coincides with the one of the lines given by ax square plus 2hxy plus by square is equals to 0. Means what? This is the joint equation of two lines, and one of the lines coincides with this line. Means the slope of that both the lines are same, and therefore to solve this problem, we'll first find out the slope of the line, convert this into auxiliary equation, substitute the value of m, and then you will get the required condition. Now see this. The auxiliary equation of the lines represented by ax square plus 2hxy plus by square is equals to 0 is dividing the whole equation by x square. Then you will get here a. What is that? Here you will get, if you divide by x square, here you will get a plus 2hy upon x and plus b, here y upon x bracket square, and that's equals to 0. Y upon x is n, therefore this is a bm square plus 2hm plus a is equals to 0. Given that 4x plus 5y is equals to 0 is the one of the lines represented by ax square plus 2hxy plus by square. Now what is the slope of this line? To find out the slope of the line, we can write 4x plus 5y can be written as, that is a 5y is equals to minus 4x, and therefore y is equals to minus 4 upon 5x. This is the equation of the line in the form y is equals to mx. What is the coefficient of x? Is minus 4 by 5. The slope of the line is minus 4 by 5. My m is equals to minus 4 by 5 is the root of auxiliary equation, which is that bm square plus 2hm plus a is equals to 0. Substitute the value of this m, minus 4 by 5. Therefore you will get b minus in bracket 4 by 5 bracket square plus 2h minus 4 by 5 plus a is equals to 0. Now we will simplify this. How to simplify? That is a 4 square. Here is a 4 square. B, 4 square means what? 16b. 5 square is a 25 minus 2 into 4 is 8 minus 8h upon 5 plus a is equals to 0. Again to simplify this, multiply this whole equation by 25, and then you will get 16b minus 5h into again 5. You will get 40h plus a into 25, that is a 25a is equals to 0, and hence 25a plus 16b is equals to 40h. That's we want to prove this. Next, if the line 3x plus y is equals to 0 may be perpendicular to one of the lines given by ax square plus 2hxy plus by square is equals to 0, and the solution. Okay, the auxiliary equation of the lines represented by ax square plus 2hxy plus by square is equals to 0. एवढं झाल्यानंतर आपलं auxiliary equation हे पाठच झालं पाहिजे. म्हणजे काय? its equation is a bm square plus 2hm plus 2hm plus a is equals to 0. Since one of the line is a perpendicular to the line 3x plus y is equals to 0, म्हणजे त्यातली जी एक लाईन आहे त्या लाईनला ही लाईन कशी आहे तर परपेंडिक्युलर आहे. देन व्हॉट विल द स्लोप ऑफ दॅट लाईन? द मायनस अँड रेसिप्रोकल ऑफ दिस लाईन which is a 3x plus y is equals to 0. Therefore, first of all, we'll find out the slope of this line. 3x plus y is equals to 0 means what? Y is equals to minus 3x. This is the slope of line. But our slope of required line is, that is a m is equals to minus and reciprocal of this line. Means what? It is a 1 by 3 minus, and that minus and minus that will become plus. Minus and reciprocal of this minus. Okay. And here you will get the 1 by 3. Okay. The slope of the line m is equals to 1 upon 3. M is equals to 1 by 3 is the root of that our required auxiliary equation. And therefore here bm square plus 2hm plus a is equals to 0. Substitute the value of m, that is a b in bracket 1 by 3 bracket square plus 2h in bracket 1 by 3 plus a is equals to 0. Now simplify this. That is a b 1 by 3 square means what? 1 upon b square b upon 9. Next is a 2h upon 3 plus a is equals to 0. Again multiply this whole equation by 9 and then you will get b plus 6h. If you multiply here by 9, then here after the simplification you will get 6h and here is a 9a, that's equals to 0. And hence therefore 9a plus b plus 6h is equals to 0. This is the required condition. Next problem. If the one of the lines given by ax square plus 2hxy plus by square is equals to 0 is perpendicular to px plus qy is equals to 0, and then show that ap square plus 2hpq plus by square is equals to 0. Means what? The one of the lines from the joint equation is perpendicular to this line. Then what we have to do here? Find the slope of px plus qy is equals to 0. After finding, make it a minus and reciprocal. Substitute the value of that m, the auxiliary equation, that is a bm square plus 2hm plus a is equals to 0. Now see this here. The auxiliary equation of the lines represented by ax square plus 2hxy plus by square plus 2hm. This is the h. Okay. This is the 2hm. I will write again here. 2hm plus a is equals to 0. Since one of the lines is perpendicular to px plus qy is equals to 0, whose slope is? Now what is the slope of this line? That is, I can write here qy is equals to minus px. Therefore what is its slope? That is a minus p upon q into x. The slope is a minus p by q. Then what is the slope of our required line? It's a minus and reciprocal of this, which is a minus, and that minus and minus will become plus, and reciprocal of this is a q upon p. Therefore the slope of the line is equals to m is equals to q upon p. Therefore m is equals to q upon p is the root of the auxiliary equation. That is a bm square plus 2hm plus a is equals to 0. And substitute the value of this m, which is the q upon p. That is a b in bracket q upon p bracket square plus 2h. Substitute the value of again m. What is that? Q upon p plus a is equals to 0. Okay. Then after simplification, what you will get? Keep this b as it is. Q square upon p square plus 2h into q upon p plus a. Now what is the LCM here? That is the p square. Now multiply this whole equation by the p square. Then you will get bq square. Here is a bq square. If you multiply by p square will get cancelled. If you again multiply here p square, then again 1p get cancelled. You will get 2hpq. There is a 2hpq. Again multiplied here by p square, that is ap square. Therefore ap square plus 2hpq plus bq square is equals to 0. This is the required condition. Now the next problem. Find the combined equation of the pair of lines passing through the origin and making an equilateral triangle with the line y is equals to 3. Now see this here. Our coordinate geometry. Here is the x-axis and this is the y-axis. Okay. The line y is equals to 3. I will write here x-axis and this is the y-axis. If we draw the line y is equals to 3. Here is the y is equals to 3. And the other two lines which passes through the origin, they make the equilateral triangle with this y is equals to 3. This is the first line and this is the second line. Okay, you can see the picture more correctly in the next. This is measure of angle 60, measure of angle 60 and the measure of angle 60. Then we want to find out the joint equation of these two lines. This is the L1 and this is the L2. Okay, now see this. OA and OB are making an angle of 60 degree and 120 with the positive direction of the x-axis. Suppose this is the O and this is the A. OB, this is the B. Now measure of this angle is 60, measure of this angle is 60 and its a total angle is a 120. And what about the measure of this angle? And it is a 60 degree. Therefore the angle made by the L1 is 60 and L2 is a 120 degree. That is OB angle. Slope of OA, it makes an angle of 60 degree. What's the tan 60? Is root 3. Equation of the line OA is y is equals to root 3x. That is a root 3x minus y is equals to 0. Now see this here picture. Y is equals to 3. The two lines passes through the origin OA and the OB makes the equilateral triangle. Therefore the first angle is 60 degree and second is a 120 degree. And here the slope of OB. The OB makes an angle of 120. To find out the value of 120, we can write tan of 190 plus 30 and it becomes minus cot of 30. And what is the value of cot 30 is a root 3. Therefore m is equals to minus root 3. Equation of OB. It's of the form y is equals to mx. That is a minus root 3x and hence it is written as root 3x plus y is equals to 0. These are the two separate lines, equation 1 and the equation 2. And their required joint equation is a root 3x minus y into root 3x plus y is equals to 0. A minus b into a plus b. A square minus b square is equals to 0. That is a 3x square minus y square is equals to 0. This is the required joint equation of lines. Okay. Now the question number 8. If the slope of one of the lines given by ax square plus 2hxy plus by square is equals to 0 is 4 times the slope of the other, then show that 16h square is equals to 25ab. It means that the m1 and m2 are the two slopes of the lines. And then what is that line joint equation? Ax square plus 2hxy plus by square is equals to 0. Again the sum of the slopes m1 plus m2 is a minus 2h upon b. m1 into m2 is a upon b. And the next is a we are given that m2 is equals to 4 times m1. Now what is the m1 plus m2? m1 plus m2 is a minus 2h upon b. And here we substitute the value of m2, which is the 4m1 that we have decided. And therefore m1 plus 4m1, that is a 5m1, that is equals to minus 2h upon b. And therefore m1 is equals to minus 2h upon 5b. Again m1 is equals to, that is the product of the slopes, means what? m1 into m2. m1 into, but m2 is a 4m1 and that is equals to a upon b. And what about their product? That is their product is a 4m1 square is equals to a upon b. Therefore m1 square is equals to a upon 4b. But what is the value of m1? The value of value of m1 is a minus 2h upon 5b. Minus 2h upon 5b bracket square is equals to a upon 4b. Their squares, that is the 4h square upon 25b square is equals to a upon 4b, and their simplification. That is a here 4h square upon 25b square is equals to, here you will get, that is a bb get cancelled on both sides of the denominator and you will get 4h square upon 25b is equals to a by 4, where b is not equals to 0. And after simplification, that is a cross multiplication. That is 4h square into 4. We will get 16h square. 25b into a, 25ab. This is the required condition. Now next problem, problem number 9. If the one of the lines given by ax square plus 2hxy plus by square is equals to 0, bisect an angle between the coordinate axes, then show that a plus b bracket square is equals to 4h square. The auxiliary equation given by ax square plus 2hxy plus by square is equals to 0. If the one of the line bisect means what? This is the coordinate of our geometry. Okay, this is the x-axis and the y-axis. It may be have like this. It's bisect the angle between the coordinate axis. It may have the also this angle. This total angle will be, that is a 135. Okay, these are the lines. Okay, since the one of the line bisect the angle between the coordinate axis, it means that again I will draw here figure. This is the x-axis and this is the y-axis, x and here is a y. It bisects the angle between them. This is the first angle. Okay, the angle may be here 45 degree first. Second, if it may be in this form, it passes through from the second and the fourth quadrant, and the measure of this angle is a 135, or that is equals to 3 pi by 4. Okay, and therefore with the positive direction of the x-axis, slope of the first line, that is the slope of this line L1, and here is the slope of the another line, that is slope of the line tan of 45 or the tan of 135, that is m1 is equals to tan of 45, that is 1, and tan of 135, that is 180 minus 45, that is a minus tan of 45 by allied angle. Tan of pi minus theta is minus tan theta, and tan 45 is 1. Therefore m is equals to minus 1. Therefore we have the two types of the slopes, that m is equals to plus or minus 1 are the roots of that auxiliary equation, and we know the auxiliary equation bm square plus 2hm plus a is equals to 0. Now substitute here the value of m, that is a plus or minus 1 bracket square plus 2h plus or minus 1 plus a is equals to 0, and if you simplify this, then you will get the square of plus or minus 1 bracket square is a b, next is a 2h plus a is equals to 0, and here you will get a plus b is equals to minus or plus 2h, and the squaring on both sides, you will get a plus b bracket square is equals to 4h square, and this is the required condition. And in this way I had completed the first exercise 4.1. I hope that you have understood all the problems whatever that I explained. Now we'll see in the next video. Till then, goodbye.